Welcome to the Jellyfish Swarm. This is our first and it probably will be our only video, and then it's our math class, so I don't really know yet. So what we're doing here today is trying to prove the quadratic formula using the completed square method. Now, what do we use the quadratic formula for? I'm glad you asked. No, you didn't. I'm still going to tell you. Good. So we use it to find x when y is equal to 0 in a quadratic equation, which is this thing right here. Now, the tricky thing with quadratic equations is that at any point you could have 0, 1, or 2 different values, which makes it kind of tricky to find. And now, we typically find it, we use this little sucker right here, the quadratic formula, as I said. Now, how do we know this is correct? We don't. So we're actually going to prove it using the complete the square method. Now, the first thing you want to do is isolate x squared. And the way you remember this, because there's a whole bunch of steps, is that you say your x, they want to be single. They want to get away from you. So what do? You isolate them, right? So to do this, you divide everything by a. By dividing both sides of the equation by a, you make sure it stays the same. It just looks a little different. Now what you have here, you have x squared plus bx over a plus c over a is equal to 0. The 0 stays the same because 0 divided by anything is 0. So now we have x squared plus bx over a plus c over a is equal to 0. Now what do we want to do? We want to get c over a onto the other side of the equation to give the x's a little bit of alone time. So to do this, we subtract both sides by c over a. Now because of the subtraction property of equality, the equation is still the same, like last time when we divided everything by a. So now we have x squared plus bx over a, and because c over a will be sorely missed, we'll leave a space there to remind us of it. It's equal to, now whatever we do to one side, we do to the other, we add another space minus the c over a we did over here. We got from over here. So now we have x squared plus bx over a plus a space is equal to space minus c over a, which is still the same as the original quadratic equation, which means we haven't changed a bit. Okay, so right now we have x squared plus b over a times x plus space is equal to space minus c over a. So right now you're probably confused why b over a times x is here right now, because previously I had bx over a. This is the same thing, so you don't have to worry. But it's going to make your life a little bit easier. So what you have to do to fill in the spaces is get b over a, right here, b over a, and divide it by 2, or multiply it by 1 over 2, which is the same thing. So in the end, we have b over 2a. 2a look familiar? Yes, it does. Good. So b over 2a is equal to b over 2a, because what we do to one side has to be done to the other. So I'll let you guys in on a secret. Right now, I have been setting you up. And what have I been setting you up for? To factor this side of the equation. And factoring on this side won't affect this side at all. So don't worry. So to actually prepare, the last step for preparing to factor this is squaring this. And because what you do to one side has to be done to the other, b over 2a is going to be squared on both sides. Okay, so right now we have x squared plus b over a times x plus b over 2a squared is equal to b over 2a squared minus c over a. So what do we have to do now? We have to factor it. So what we have to do to factor it is get these two parentheses set up. And because we actually set it up to be factored really nicely, we know that x plus b over 2a times x plus b over 2a is equal to this. So we don't have to worry about it. So now what we have to do here is simplify this. So we got b squared over 2 squared is 4, a squared minus c over a. Okay? And this can be further simplified into x plus b over 2a squared, and that will be equal to b squared over 4a squared minus c over a. Okay, so right now we have x plus b over 2a, all of that squared, is equal to b squared over 4a squared minus c over a. So we're nearing the final line. So what do we have to do? Well, c over a is feeling kind of lonely. So what can we do? We combine it with what? This fraction right here. So the only problem is that a and 4a squared are not equal. And because fractions with uncommon denominators, unlike denominators, can't be mixed, CA is forced to be alone. But we can change that. How? We change its denominator. So, by changing its denominator on the bottom as well as on the top, the fraction effectively stays the same. So, we know that the denominator has to be 4a squared. How do we do that? Now, how do we get from a to 4a squared? All we have to do is multiply 4a. So, c times 4a is equal to 4ac. So now we have b squared minus 4ac divided by 4a squared, which is equal to x plus b over 2a squared. So right now we have x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. So we can simplify this by taking the square root of this, and what we do to one side, we do to the other, so we get the square root of that too. So this is simple. X plus b over 2a squared, the square root of that, we just take out the square. So now we just have x plus b over 2a. It's equal to, so because it's a fraction, we split up the square root. So this, we get a square root of b squared minus 4ac over, now this is a little easier. So the square root of 4, that's 2. And the square root of a squared is a. So now we're in the home stretch. So right now, x plus b over 2a. So we got x, we just need to get it alone. So we just have to subtract b over 2a from both sides. And there we have it. X is equal to negative b from here, plus or minus, because the outcome of a square root could be positive or negative, b squared minus 4ac all over 2a. And that's about it. Thank you.